All right, we are going to factor this. So the first thing we want to do is try to factor out the greatest common factor. So we look here, and we look here, and we say, is there something that these have in common? We want to factor out the greatest common factor. Well, notice they both have a 25, so we could factor out a 25. So it's going to look like that. So we factored out a 25, and we can double check it. This times this is that, and this times this is that. Now we're going to factor this part again. It is the difference of two cubes. This is a perfect cube because x times x times x equals x cubed. And 1 is a perfect cube because 1 times 1 times 1 is 1. So this is a difference of cubes. And so what you do is, of course, you put that 25 down. And when you know that you have a difference of cubes, you want to have a short set of parentheses and a long set. The short set is going to have 2 blanks to fill in, and the longer set is going to have 3. Now this short set comes from here. The first blank is, what is it that makes that a perfect cube? Well, we said it was x, because x times x times x is x cubed. And what goes here is what makes that a perfect cube. Well, that's a 1. This sign is going to be the same as whatever's here. So if this had been an addition sign, this would have been addition here, but since it's subtraction, we have a subtraction. Now, all of this comes from over here. We're not going to look up there anymore. This one is that one squared. This one is that times that, which is 1x. And the sign here, the operation here, has to be the opposite of that. So if this had been plus, this would have been minus, but since this is minus, this is going to be plus. And the last blank is 1 squared, and it is always plus, no matter what. So this is how you factor a difference of cubes where we factored out the greatest common factor first. So sometimes you can factor more than once, and so you should keep factoring until you can't factor it anymore. I know this won't factor anymore. This won't factor anymore. This, you might think that it would, and you should try using the guess and check method, but you will find out it won't factor anymore. So that's how we know we're done. I have seen problems where you had to factor 3 times to get it down to its lowest factored form. But in this case, it was just 2. See ya.